Okay, hello everybody. Back again for number 7. Oh, give me a moment. Got echo. That's better. Okay, we're back for session 7 for our beginner assembly language tutorial, for want of a better word. First look, kind of exploration. And today we're going to just quickly add some very simple snappy sound effects using the 48K beeper. And to do so, we're going to actually add our own its own file for that. Oh no, not open file. Create a new file. I'm in the wrong file in PowerShell, but we can deal with that later. We'll call this SoundMaker. I'm saving it in my root folder, soundmaker.asm, and there you see it. We can now delete that. First thing I want to do is copy and paste some notes into the file so we don't have to keep looking about. I'll be explaining these in a moment. I'll have to comment it, a group comment. That's rather annoying, but there you go. Just from the way I had it laid out, it done that. So yeah, a little bit annoying. Yeah, I'll tab these out a bit. Be careful. These are frequencies for those corresponding notes. You'll need to know those in order to add go a higher, an octave higher from that. You just have to add, you double it. Okay, so that's what have I just done there? So that's that bit of notes. Here's the formula. Got that recorded here. This formula you will need in order to calculate what noise the beeper is going to make and for how long. And it seems very strange how this works at first, but eventually you realise it makes quite a lot of sense. And yeah, we'll use those in our SoundMaker. So as you can see, we've got that formula to work with. So making a sound is as simple as we'll make a function called make sound G#. By the way, capitalization doesn't matter with them, so it's not case sensitive. So you could call it that, and then later in your code call it that to refer to it, and it would still work. Let's not comment it for now. We'll load the HL register with a pitch, which, well, as you can see here, I'll get my calculator. 437500 divided by G sharp, which is 415.3. .3 take away 3. Alright, it's times by 0.5. Oh no, I've been muted the whole time. I do apologise. What I've basically just done, if you didn't follow, was I created a function specifically to make a specific sound for a set amount of time. I use that calculation to come up with those numbers. I called the inbuilt ROM routine that uses those values to create a beep. I then included it down the bottom and called it here right at the beginning of our program as soon as we clear the screen. So yeah, my apologies if that got a bit boring and confusing for you while I was just typing away silently there. I do apologise. I hope this will work after I compile it. Let's compile textmover.asm, textmover.tap, .wrap. And there you go. Very straightforward, but it does the trick for us very quickly without using a lot of processing power. Of course, it's trivial to just copy and paste that. You know, if we want to make one for the same note, but only quarter of a second, we can. The clever ones amongst you can probably do this in your head, but I'm not that clever. Maybe if I really had to, I could, but I won't be attempting it, especially live on air. There's no point. You can of course make constants for all these if you want to as well. So anyway, before I get sidetracked, the calculation is 437,500. I'm working out HL now. Divided by the frequency, which is G sharp, which is 415.3. Nothing changed there in our HL register. However, in the DE, it's going to be half the size, isn't it? But let's do it on the calculator anyway. 415.25, 1.38, 103.8. So in other words, 104. And of course, we can string these. In fact, let's try it. I don't know quite what the result will be of this, because I don't know if it'll wait until the other one's finished to begin. In fact, I'm pretty sure it won't. So to make a melody, you come up with a string of loops. You come up with a loop. I did start to create a melody in my other game. We won't be doing that just yet. That's going to be another lesson. I'll organise it. I've got it already written code, but I'll make sure it sounds rubbish at the moment, the melody I've created, so I'll make sure it sounds a bit better first. If we string these together, I'm expecting it to do nothing, actually, nothing different. Oh, whoops. Oh, it did string them. That's very good. So that function that we call inside here, this one here, that must actually suspend the operation until it's finished. Obviously, it'd be more apparent if we tried a different note. So we'll do like an A sharp. Or in fact, let's do C sharp. Still copy and paste. C# 0.25. So 437500 divided by 277 0.125. We're left with 1548. DE, frequency times seconds, 277. So that is 69. I'm quickly going to check my math on the other one. Yep, it's bang on. And we're away. Right, so we'll add that in the middle between the two. In fact, maybe might sound a little bit better with that one on the end. I don't know, I'm just guessing, but 2 short ones followed by a long one. There you go. Oh, you start game. So you got a little melody there, which is actually making me laugh because I wrote a whole routine in my other game to delay it between the rhythm of a melody, you know. But you could actually just do that, couldn't you? Just by calling it. As long as you don't want a blank space, I guess, then you'd have to put a weight, some sort of weight. I mean, you can create a weight by I'll show you very quickly. Load B 200, or let's say 10. Might not be long enough to notice. My brain can't work it out. But then create a loop, weight loop. And then DJNZ, that's going to reduce B by 1 and go back to whatever label you put here until B is 0. And actually, that's all you need. Well, we could put a halt in there. Why not? So that should wait 10 frames now. Let's put 50. Of course, you can only go up to 255 here. So 255 frames isn't a lot. You could put lots and lots of halts in here. It's going to wait more than that then, you see. So if my maths is right, 17 should be 1 second now. It should make the first noise, then wait 1 second, and then it should make 2 more noises. Bang on, see? Simple stuff. That's what I like, nice and simple. So we've learned how to create a weight loop. And in fact, as a little side, let's create another file. Now, I was going to create a file called like tools, but we don't need a file. Let's just in fact, it was quite good where it was. Let's put it right at the bottom. Okay, weight loop, and then just put a return underneath instead. So it's actually a tiny bit slower now because of that return instruction. It has to the call instruction that we're about to use is also something that uses processor and memory. Cool, weight loop. But as you can see, we've had to load B. So this is why I did this. I wanted to show you a good habit to get into is always to comment it. Creates a pause, assuming game running at 25 FPS. Right? So, well, let's not even put these brackets. Creates a pause, assuming game running at 25 FPS. B will equal seconds delayed. And then just to be super clear, we'll put inputs B equals seconds of delay. There, so we've commented it really nicely now. You know, I mean, yes, this one's called wait loop, but we've put this additional information in here. There's two halt statements. Let me think about that. It doesn't actually matter. No, that's assuming the game is running at 50 FPS. Or that it is in fact, no, it's independent of what the game's running at. I liked it having the free halts in there because it means we can use smaller numbers for the delay. But that now is frames delayed, so people can just work it out from there. Just double checking he still moves. Yeah, so now anyone using the wait loop can see that they have to put B with a value. And if we want a 1 second loop now, we'd need to change that to 50. Alright, so this is going to be the end of the lesson, isn't it? We've done the beeper. There is a couple of other little tricks you can do with it, but we're beginners here. This isn't we're not trying to master the system completely so that we know everything about it all in one go. We're just learning enough to make some rudimental games. The next thing we're going to be doing is making an array of power-ups which will spawn randomly across the screen. Some of them will be of one variety and some of them will be of another. You have to collect the ones that are the right variety. It's simple as that. Maybe we'll even go as far as adding some sort of despawn time and you know, make it so you've got to run around doing it quickly so that you might end up grabbing the wrong one or whatever. But yeah, it's going to be simple stuff. It's not going to be a game that's going to get anyone addicted for years or anything. There's not going to be any speed runs, but we're learning a lot in the process. I'm certainly learning a lot still as I go along and recap myself through all this stuff. And I'm enjoying that. There's plenty more to come. I've sort of structured what we're having next. Like I say, we're doing the spawning of those random power-ups. But there might be some other bits and bobs chucked in there. Of course, that what I've just mentioned is going to involve a random number generator, which may involve having its own lesson, but I don't think so really. But we're going to have to cover bitwise operations at some point just to make sure that people watching understand at least what I'm talking about when I say that. Okay, it's been nice again. Thank you very much. No more coding this evening for me, but I'm coming back on later with some gaming. Hope to see some of you then. That would be absolutely brilliant. Please make sure to give me a follow on Twitch. It helps me loads. Same with my YouTube channel. Go and subscribe to that. Also, there's links in the description on YouTube now where I have a GitHub. All this code is uploaded after every session to GitHub, so you don't have to type it yourself. Alright, have a good evening. Bye.